Hello, I'm Anna Mackay, and today we're looking at probability density functions. What is that, you might ask? There's a few key facts that a function has to be to fit the bill for this. If we have a function, and we are going to integrate that, so we'll call the function f of x. We've got some bounds, a lower bound of c and an upper bound of d. The area under that function has to be between those two bounds, and that area has to be equal to 1. So thinking about probability, if you add up all the probabilities of something happening, the probabilities of that equal 1. And this area now with integrals is the part of calculus. So this is kind of exciting for nerds like me in some way, where statistics and calculus meet. There's a bit of a crossover. The other requirement that has to be met is that the function must be above 0. So the y above the x-axis between those bounds, because probabilities can't be negative. You think if you've got area underneath here, you've got a negative probability of something happening, which doesn't make sense. And as I said, the total is 1. So let's do an example now. Have your graphics calculators handy. Consider the probability density function of this. 1 over 24 outside of x squared plus 1, but in the domain of 1 to 4. Now, something I say a lot is create a visual. So one of the requirements is that it must be above the x-axis between 1 and 4. So you need to check that, otherwise you can't do the whole question. So with your graphics calculators there, you're going to graph this function. Here it is typed in. Now let's start with a standard view window of 10 to 10s and see what that looks like. Now you're going to restrict your domain because we really only want between 1 and 4. So we'll restrict that in our x. You can go 1 to 4, or you could go 0 to 5 if you like. And the y values, we don't, as you saw, nothing was below the y-axis. You may not have had a chance to think about how far up or down that's going. I can give you a hint. Let's try 1. And let's see if that's the domain we're after. Yes, there we are. So we are after the area under the curve in this section, and we're hoping it equals 1. We're going to check that mathematically. And is that above the x-axis, so above 0 for the equivalent y values? Yes. So let's go back to some calculations now. So to mathematically check that, we have to take the integral between 1 and 4 for the function. Now let's integrate that. So we use square brackets to integrate. The constant, the 1 on 24 coefficient, we can just leave out the front, and now we apply the rules. So you take the power, increase it by 1 and put it over the power. So that becomes x cubed on 3, and that plus 1 becomes an x. Close that bracket, close the square brackets and put the 4 and the 1. I'm going to go sideways so that I don't run out of room. Now you're going to substitute in each of the 4 and the 1. So where I see an x, I'm putting a 4. And you use your calculator to work that out, just the run mode, and that is equal to 1. So mathematically that works, and we could also say that from the graph, the function is greater than or equal to 0 on the domain, so for all x between 1 and 4 and equal to those. I want to check that with our calculators, so back to our calculators. So here, in this graph mode, I'm actually going to just change my view window. I'm just going to go from 0 to 5, just so that we can see something a bit nicer. Now, we're going to use the integral function here. So we're going into gsolve, arrow across, here's the integral sign, and F1 here. Now it's asking you at the top, select lower limit value, so that's 1, and our upper limit value is 4, and ta-da! As you can hopefully see in the bottom left-hand corner, the integral there is equal to 1. So that's visually what we're talking about. All those probabilities for that function between that domain are equal to 1. I want to show you how to do that in our run mode as well. So let's go to menu 1. Okay, so we're going into option, calc for calculus. That was F4. F4 again, it's got the integral sign. And now you're going to type in your function, or you could type in y1. Actually, how about I do that because it's already in there. So let's see if we can find that. That'll be option. No, it won't be option. It'll be in vars, which is variables. And then we're going to graph, F4. You're going to select Y. You're going to select Y1 because you've already typed it in there, and you put in your domain, 1 and 4, and now hit enter, and ta-da, it's equal to 1. So check that in our run mode as well. Back to the second part of the question. The second part of the question is, for this function, find the probability that x is between 2 and 3. So mathematically, how we're going to write that out, our statement is that the integral between 2 and 3 for the function, this is what we're going to work out. So write out your that expression each time, and I'm going to tell you that it's 11 on 36, and we're going to go across to our calculator and prove that mathematically. So two ways to do it. You can do it in graph or run mode. Let's do this one in run. So this time I'm going to type the function in with the fraction. So in case you forget how to do that each time, putting in the bounds of 2 and 3 and 11 on 36. So that's how we get that one. Okay, that's the end of this video. Join me for the next one where we look at some more of the properties about the mean, median and modes of these types of functions. Thank you.